So, picking up from question 25, we've got we're taking an isometric drawing, we're turning it into a orthogonal drawing. This is pretty common. This is one of the most likely things to be in the exam. Now, in this case, you'll notice that it's got a threaded section. I would count on the fact that you'll probably have a threaded section. That'll be the requirement. Now, it should have an arrow. It didn't have an arrow, but there should be an arrow here pointing to this as the front. If in doubt, always you want to produce a landscape picture, not a portrait picture. I know that seems silly because our exam is in portrait. The reason why is because when you actually have the space to draw is going to be in portrait. Okay, so it also doesn't really work well if you're going to section something. It doesn't really make sense where you're going to section here, whereas if you're going to section from the front, you know that you're going to section through the axis of symmetry. Okay, that said, I did do both answers, so it was gave you a little bit of flexibility. Now, I've taken a photo of, this is my version of the answer. Now, obviously, mine is not drawn to scale. Mine is not dimensionally accurate. So because it's not dimensionally accurate, I would lose one of those 5 marks, right? So probably one of those marks is going to be for having your drawing be the right size and dimension. Now what they do is they put a overhead over the drawing and they see whether or not the dimensions line up, right? Whether or not the shape fits. Now, I would suggest even if you didn't bring a set square into the exam, even if you think that you're going to, I don't bother with drawing questions. They're not worth the effort. They're not worth the effort. I would suggest still draw a hand-drawn sketch like this, and you might get 2 or 3 marks. And 2 or 3 marks could easily be the difference between a band 6 or not. Okay, so I'll put it to you this way. It's very, very, very difficult to get a band 6 if you're going to ignore the sketches. Now, here's what we need for the other 4 marks. Right? First of all, I need to see a difference between light and dark lines. Right? That's, in my case, in my marking, that's worth 1 mark. A difference between light and dark and thin and thick lines. So when I say thick and thin lines, okay, light and dark lines is construction lines. I drew this whole thing without any construction lines. If I was to draw construction lines, my construction lines would be here, and that lines up my views. Yeah, so I would have a line that lines up this view here and this view here. That should be a thin line. That should be a light line, a thin light line. Now, all of our shapes, every part of the shape that is any part of this section that we cut through, or in a non-section drawing, every line that is not a section line or a center line, they should all be drawn as thin dark lines. So in this here, I've drawn the blue lines represent my thin dark lines. Now, you will also have to section. When you section, I suggest that you use a ruler and that you have the spacing, use the spacing evenly. A way to do this, and I've shown this to you before, is to use your set squares and to just move your set square up the distance of the marking for your measurements on the line. That will give you nice consistent lines. Sometimes you have to section 2 different materials. If you do that, I suggest the requirement is you use different angles. So you do this one at 45 degrees this way, you do the next one at 45 degrees the other way, and then the third one you do at 30 degrees. It doesn't have to be exactly 40 degrees or 45 degrees. Just as a guideline, 45 degrees tends to be pretty common. If you're cutting through something that is 45 degrees, it's suggested that you go at a different angle so that it makes it clear. Okay. So sectioning lines, so what we need to do is we need to have our thread, because the thread is cut into the metal, the broken line has to be into the metal. Yeah? Same thing here, they drilled the hole, and then we're cutting this thread here into the metal, right? So that's going to be a thin, dark line. These section lines are thin, dark lines. Now, I just want to get the dimensions. This is really important. Just 1 second. This here says it's an M10 bolt. That means, in that situation, if that's an M10 bolt, this broken line is the 10 mil. This here is the 10 mil. So, to know the difference, to know that spacing, to know what that spacing is going to be, right? We have to know now how much our depth is going to be, our thread depth. We're given the pitch. What is the thread depth equal to? Half the pitch. That's right. So, in this case, 2 lots of half is 1. So this diameter, if that was 10, you're going to have the internal diameter, what we call the d min. Guys, what we call the d min. The d min is equal to when they have a fine. This is a fine thread. We know that d min is d minus pitch. Yeah, right. So that's the picture of Gosling. Right, he's fine. D minus pitch. So that's the d min is going to be 8 in this case. So that should be 8 millimeters, and this big one here should be 10 millimeters, and that's the broken one. Yeah. If we're not given that, the d min is what percentage? 0.8 or 80%. That's right. Okay. So let's go through the marks. 5 marks. 1, dimensional accuracy. Maybe even 2 marks for dimensional accuracy. Another mark is for putting the views in the right spot. Right? The top view goes on top. I must admit, I haven't done some drawings for a while. When I was marking this and I was drawing some drawings on your things, I didn't always put the top view on top. And I thought, oh, that's silly. Right? You guys are going into an exam. You want to be thinking top view on top. When you see a drawing, say in your head, top view on top. Right? Use that memory. Use that. Actually say that in your head so that you remember top view. If you're doing a practice paper, say out loud, top view on top. Right? Remember that you need to put your top view on top. They need to line up. Right? So those 2 things are worth a mark. Right? We need to see a difference between your line types. So I need to be able to see a difference between thick dark and thin dark lines. If you have construction lines, they should be thin light lines. That's 3 marks. You need to remember to have center lines and sectioning. Right? Center lines are important. Sectioning is important. So all of those things together are worth 5 marks. Okay. That was a lot of talking. We're going to move on. CAD is the most commonly used way engineers produce technical drawings. Explain the benefits of CAD compared to drawing by hand. Now, I try and talk about this at least once a semester. It's a question that's commonly asked. What they're asking is, what are the benefits? Now, the thing that everyone wants to say is they want to say speed, they want to say accuracy. The fact is that these are marginal benefits. Yes, they are faster. Right? I personally believe that they are fast. I've seen people draw quality drawings by hand. I've seen people draw quality drawings by electronically. The big advantage is not so much that they're faster in the short term. The big advantage is that they're easy to modify. Right? If you have to modify a sketch, now in engineering, a big part of my job, every morning I'd get a phone call from site, and they'd say, "Look, we've found this complication. We need to modify the drawings," and we'd modify the drawings. And we did that pretty much, once a week at least. I would do a sketch that was a modification of our original plan. And every time, that only took the drafter maybe 2 or 3 hours, whereas to redraw the whole drawing would have taken a day. Yeah? Maybe days. Right? It's much harder to redraw a drawing every time. So modification is the benefit. Right? Accuracy. Now, a lot of markers will tell you that the original drawings were pretty damn accurate. Here's the advantage, I would say. Integration with survey. Yeah? Things like total station, so that I can get those survey points, I can get pipeline dimensions off the drawing, I can measure things virtually on my drawing, and I can get exact measurements to the millimeter off the drawing. I can go onto my AutoCAD reader and I can read the survey drawings and get exact dimensions. And often did. Right? When installing pipelines, I would know exactly how much clearance I had because I could measure off the drawing. Now, I can't do that when I've got a paper drawing that's 1 to 100. Yeah? So that's an advantage. So rather than saying speed and accuracy, what I would say is easily modified, digital copies can include exact dimensions. Right? Then we talk about the ability to be stored and the ability to be shared. Right? There's a lot of benefits there. Now, it's an explain question. When we have the keyword explain, that means we have to have cause and effect, right? These things result in this benefit. So if I wanted to say CAD drawings can be modified more easily, this results in a reduction in delay and the reduction in labor costs. That's one benefit, right? If you wanted to give 2 benefits, right, that would probably, technically you've explained a benefit. It does say benefits. So another benefit is that CAD drawings can incorporate actual survey data, which makes them very accurate, which means that designers can measure off the drawing with perfect accuracy. That would be is a cause and effect. Okay. Oh, the effect of that being more accurate and faster designs. CNCs is a great answer. Thank you very much for saying that. I had forgotten. I was very impressed when I read that. Yes, the fact that they can be integrated with digital production methods is really important. Okay, also people talked about we can now have 3D models where we can rotate and see different perspectives and different views is very important. Tiffin, can you close that window? Okay. Outline the value of engineering reports. Okay, so it's only 2 marks. Really, I'm happy with 2 sentences here. Engineering reports. Engineering reports are very useful because they allow us to plan our work and they allow us to report on work that has been done. It is important for research that it can allow us to provide accountability, and it can allow other people looking back on the project in the future to understand where we got our sources. Okay, so outlining. I would say, so a lot of good answers. This is pretty flexible, but I would say, so it allows us to plan work to make sure that everyone agrees with what we're doing before we start. That's an important part, right? It also allows us to record the actual outcome of work, so that we have a historical record in case of legal disputes or people need to provide further information to future designers or future researchers. It also allows us to record our assumptions and our sources for information. So it's 3 different things. I'd be happy with any of those two of those things. Okay, drone. Describe. It's 3 marks. Describe how it achieves flight. Now this is from a past HSC question. We talked about this in our review. Now, first of all, we talked about there's several different answers you can give for how something achieves flight. You can talk about Bernoulli's principle, which is that the propeller, as it moves through the air, creates an area of high pressure below the wing, low pressure above the wing. This creates an upward force. That's one answer. You can talk about the turning, the conservation of forces, right? So that as the wing pushes into the air particles force the wing, force into the wing, which creates a resultant force pushing the wing up. The reality is that it's a combination of all of these things, and any of those answers is pretty good. I'm happy with any of those answers. Usually I talk about the low pressure area, an area of low pressure above the wing. That's usually the answer I give. You can use multiple. Now, in the case of this, how does this particular drone achieve flight? Because it's 3 marks, I'd suggest going the extra mile there and saying it achieves flight. It can be controlled by the 2 propellers counter each other. So with 2 of them going clockwise, the other 2 go anti-clockwise, which means that they can maintain a stable position, a stationary position. It also is important that we can increase or decrease the speed of some of the rotors in order to control it to move forward or back. Yep, so that's what we're looking for 3 marks. Okay, aluminum alloys are identified by a 4-digit code. What is the main element in alloying element in 2017? Exactly right, copper. Copper is a 2000 series aluminium. Anything 4-digit number that starts with 2 is going to be copper. Right, we've talked about the other important ones. 6 is magnesium, 7 is zinc. They're the important ones. They're important because they're heat treatable, exactly right. These days, so 2017 is called, and I always struggle with this, duralumin, but 2017 has been replaced these days with 2024. Whichever helps you, whichever one you can remember is fine. An important aluminium alloy that we use is Alclad, which is usually duralumin, or 2017, 2024, coated in a 1 or 2 millimeter thick layer of pure aluminium. That's called Alclad, and Alclad's pretty important. It's one of the main ways that we prevent corrosion in aviation. Okay, identify, it says this is a 1-mark question, identify the function of a pitot tube. Anyone? Airspeed, thank you. Okay. Now, I would think that this is a everyone should have expected this question. I think it was answered pretty well. Okay, aileron.